Okay, this is chapter 8.1, similar polygons. The essential question is, how are similar polygons related? What you will learn is how to use similarity statements, find corresponding lengths in similar polygons, find perimeters in areas of similar polygons, decide whether polygons are similar. Okay, so let's take a look. For concept first and an example. Okay, corresponding parts of similar polygons. In the diagram below, we have a triangle ABC in blue. Okay, so here's triangle ABC. Capital letters are for vertices. Lowercase letters are for side names. Capital ABC triangle is similar to triangle DEF. You can write triangle ABC is similar to DEF as a triangle symbol, ABC, 1 tilde or squiggly line, triangle DEF. So triangle ABC is similar to triangle DEF. If a second one was there, then that'd be congruent. Actually, not a second one. No, I'm sorry. Congruent would be an equal sign with a squiggly line underneath. And if there was only one squiggly line under there, like so there's two, that'd be is approximately. So that doesn't not what we're doing here either. So this is similar. A similarity transformation preserves angle measures. So the measure of angle B is congruent to the measure of angle E. Angle A is congruent to D. Angle A congruent to D. And angle C is congruent to F, as it said here. The relationship of the sides, a similarity transformation also enlarges or reduces the side lengths by a scale factor K. Scale factor K. So if K is greater than 1, it makes it larger. And if K is less than 1 but greater than 0, it shrinks it. Okay, so this blue triangle ABC is similar to triangle DEF, but this is a larger triangle, so we know that the K factor is greater than 1. So corresponding side lengths are also proportional. So you could say side DE is to AB as EF is to BC as FD is to CA, and they're all equal to that K scale factor. All right, so let's take a look at that in an example. Okay, so here's example 1 using similarity statements. So it says in the diagram, triangle RST, this triangle here is similar to triangle XYZ right here. So we're going in this direction. So XYZ is smaller. So you want the smaller number in the denominator because or in the numerator. Okay, so let me explain that. If I put well, first of all, it says find the scale factor. So RS corresponds to XY just by looking at the name here. So here's RS and here is XY. I do not want to write our RS over XY. Don't write this, just listen first. I don't want to write it this way because when I substitute in my givens 20 RS is 20 over XY, which is 12. Well, that's going to reduce to 4 will go into 20 5 times, and 4 will go into 12 3 times. So I have 5 over 3. But the problem with that is that is greater than 1, and that'd be an enlargement. So that would be going from XYZ to RST. We want to go big to small. So I want to flip this. So this is upside down. So I want a fraction less than 1. 5 over 3 is greater than 1, and that's an enlargement. 3 over 5 is less than 1, and that's a reduction. Okay, so I don't want RS over XY. I want XY over RS. Okay, so when I substitute in that value that I just had again, I'm going to say 12 is to 20. And that reduces to 4 goes into 12 3 times, and 4 goes into 20 5 times. And then I'm going to just do this. Let me change colors now. And now we have ST and YZ. So here is ST, and here is YZ. Again, we're putting the smaller one on top. So I'm going to say y z is to st. So yz over st, which is 18 over 30, and 6 will go into 18 3 times, and 6 will go into 30 5 times. So notice they're equal. And continuing with this, now let me erase these. Then I'm going to say, well, the first letter and the last letter, RT is a side. So here's RT right here. And XZ is over here. Okay. So you're going to put equals XZ over RT, which equals 15 over 25, which equals 5 goes into 15 3 times, and 5 will go into 25 5 times. And we have 3/5, 3/5, 3/5, and they equal our K. So that is K, scale factor. So this is A. B says list all pairs of congruent angles. So again, let me erase these dots up here. Do them one at a time. Angle R corresponds to X. So for part B, I would say angle R is congruent to angle X, comma. So that's the first and the first. Angle R is congruent to angle X. The next one, let me do it in green. S is congruent to Y. Angle S is congruent to angle Y. And then finally, TZ, comma, angle T is congruent to angle Z. Okay, so those are the three angles that are corresponding, or congruent, I mean. List all pairs of congruent angles, and I haven't labeled them here. I said R had one arc, X has one arc. S and Y, S has two arcs, Y has two arcs, and Z I'd put 3, and T I would put 3. And then finally, part C, it says write the ratio of the corresponding side lengths in a statement of proportionality. Okay, so I've already done that. When you're doing finding K, this is part C. Right there. Okay, I always like to just do it all at once, finding the proportionality. When you find the scale factor, if you list them all first, then you're writing the ratio of corresponding side lengths in the statement of proportionality at the same time. Okay, so now that I've done this, you should be able to do problem number 3 in your exercises. Okay, one more core concept, corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. And I just showed that right here. Okay, so any two corresponding lengths are equal in scale factor to the similar polygon. So XY to RS was 3/5, YZ to ST was 3/5, XZ to RT was 3/5. Those are all equal to the scale factor. That's all the corresponding lengths of similar polygons says. And so let's take a look at an example again. Okay, here's example 2. It says find a corresponding length in the diagram. Triangle DEF is similar to triangle MNP. So this triangle is similar to this one. MNP is bigger. It says find the value of X. Okay, so first of all, you want to highlight or identify what you're trying to find. And it's side EF. Okay, so I do want to have a side correspondence equivalence. So you take EF. Well, what does EF correspond to in this one? Always look at the name. It's second and third letter, second and third letter. EF is to NP, like that. And then we don't know this side. So we always pick a side that we don't know and the side that we do know that it corresponds to, along with something we know both. So then I'm going to choose ED in this case, and I'm going to say ED corresponds to, and if I look up at the name, ED is the first two letters, that corresponds to NM. Okay, it doesn't matter which two you choose as long as you're choosing one that has the missing value. So then all I have to do is substitute in my givens. EF is X, NP is 30, equals ED, which is 15, over NM, which is 18. And then to solve for X, we just cross multiply. So 18 times X is 18X equals 30 times 15. So it's going to become 18X equals, well, 30 times 10 is 300, and 5 times 30 is 150. So 30 times 15, we could also put a 0, and 3 times 5 is 15, carry the 1, 3 times 1 is 3, plus 1 is 4. We have 450 divided by 18, and those cancel, and I get X equals 18 times 2 is 36 with the remainder of 9, so it's going to be 5. So the value of X is 25. Okay, so that's how you find a missing value using proportions. X equals 25. Okay, so now you should be able to do problem numbers 5 and 6 in the exercises. Okay, example 3 says finding a corresponding length in the diagram, triangle TPR, this triangle right here with the red altitude drawn at 90 degrees, is similar to triangle XPZ. So these two are similar. Okay, find the length of the altitude PS. So what we're trying to find, let me switch to my highlighter and let's make it a little thinner. How about that? This is what we're trying to find right there, PS. All right, so let me see. So we know TR. So we're going to first start off with side TR. TR is the first and the last letter. Well, that corresponds to the first and the last letter in the other triangle, which is XZ. And see what they equal is TR is TS plus SR, or 6 plus 6. So the total length. And XZ is XY plus YZ, which is 8 plus 8. So TR is 12 and XZ is 16. So that's the first step. So 12 over 16, if I reduce that, 4 will go into 12 3 times, and 4 will go into 16 4 times. So my scale factor is 3/4. Okay. Okay, so since that is the ratio of each side, we can now say, well, now we can find SP. So now I can say SP, which is what we're trying to find, is to SP is to YP as TR is to XZ. So SP, we don't know. I'm going to call it X. YP is 20 equals TR, which is 12, and XZ, which is 16. But I can reduce that so our numbers aren't so large. I can use this 3/4, and that's what I'm going to put here. I'm going to put 3/4. So X over 20 equals 3/4. So when I cross multiply, I get 4X equals 60, and then divide by 4, X equals 4 goes into 6 once, 4 goes into 25 times, and that was my SP. So therefore SP equals 15. Okay, so that's how you use the scale factor and proportionality to find missing sides. So now you should be able to do problem numbers 9 in your exercises. Okay, theorem 8.1, the first theorem of chapter 8, perimeters of similar polygons. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So if polygon or quadrilateral KLMN is similar to quadrilateral PQRS, then the side PQ plus QR plus RS plus SP equals KL, or over, divided by, KL plus LM plus mn plus nk, which would equal PQ over KL plus, which is equal to QR over LM, which is equal to RS over MN equal to SP over NK. So what they're basically saying is if you add all the sides, that's perimeter, and then break up each side with its corresponding side like so, and set those all ratios equal, and that would be your scale factor K, then the two polygons are similar, then the ratios of their perimeters is equal to the ratios of their corresponding side lengths. Okay, so if I added that all up and added all those up, the perimeters ratio would be equal to each side's ratio if they're similar. That's all there is to it. It's pretty simple. There is a proof on page 426 and example 52. So let's take a look. Okay, example 4, modeling with mathematics. A town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters. I'm sorry, 50 meters. I got distracted when my highlighter wasn't as thick as I wanted it to be. With length of 50 meters and a width of 25 meters. The new pool will be similar in shape. So there's the key there. They're going to be similar to an Olympic pool, but it will have a length of 40 meters instead of 50. Find the perimeter of the Olympic pool and the new pool. Okay, so what we have to do is we have to remember this here, where if the perimeters are similar, then each corresponding side has the same similar ratio or K factor. So we want to find the scale factor of the similar rectangles and find the perimeter of the Olympic pool. So to solve the problem, the scale factor is a ratio of its lengths. So what we know are these two lengths right here, the length of 40, the length of 50. Okay, so our scale factor will be 40 to 50, which reduces to 4 over 5. Okay, so that is our similar, or that is our scale factor K, which equals K. Okay, so it was just the lengths of the two pools. We didn't know the width of the copy, but the width of the Olympic pool is 25. So now what we have to do is find the perimeter of this. So if this is 25 meters and this is 50 meters, well, perimeter equals 2 times L plus 2 times W, or you could write it as 2 times L plus W if you factor out that 2, which is 2 times L 50 plus 25. And 50 plus 25 is 75, and therefore 150 meters is the perimeter of the Olympic pool. So now we know a scale factor. So we now say, well, what the question is find the perimeter of the Olympic pool and the new pool. So there's the perimeter of the Olympic pool. That part's done. But now we want to find the perimeter of the new pool. So we're going to take the sides, which were, whoops, I don't want the 40. Might as well reduce it and keep it simple. 4 over 5 was the ratio of the sides, equals the ratio of the perimeters, which is, we don't know, and 150. Cross multiply, I get 5x equals 4 times 150. I'm just showing all my work. And 5x equals 600. Divide by 5, divide by 5, x equals 5 goes into 6 once, 5 goes into 10 twice, 0. So the perimeter of the new pool is 120 meters, and the perimeter of the Olympic pool was 150 meters. Okay, and that's it. So now that you've done that, and this is also the key here, the ratio is 4/5. So now that we've done this, you should now be able to do problem number 17 in the exercises. Okay, theorem 8.2, second theorem of the chapter, areas of similar polygons. If two polygons are similar, then the ratio of their areas is equal to the squares, okay? Because areas multiplying length times width of the ratios to their corresponding side lengths. So if If quadrilateral KLMN is similar to quadrilateral PQRS, then the area of PQRS over the area of KLMN is equal to the sides proportions squared on all of them. Okay, very similar to the last one, but perimeter is length, it's distance, it's one-dimensional. Area is two-dimensional, length times width. So we square it. So the areas are, whatever you find the ratio here, then that would be the ratio of the sides squared. So let's take a look at how that would look in an example. Okay, so now we're putting 8.2 into practice here. And it says in the diagram, triangle ABC is similar to DEF. Find the area of DEF. So what we're trying to do is this. And here's what we know. And then what do we know about the sides? Well, AB is right here. It's 10. DE is right here. It's 5. AB is the first two letters. DE is the first two letters. So the sides correspond. Just checking everything. And here's what we write. We say, well, if the area of triangle ABC divided by the area of triangle DEF is going to equal one side corresponding to the other. So it's AB over DE. And that's going to be squared. So I'm just following this rule right here. Area divided by area equals side divided by side quantity squared. That's all there is to it. It's pretty simple. Now I'm going to substitute in my givens. So the area of triangle ABC is 36 centimeters squared. I'm just going to write 36 for now. And I don't know the area of triangle DEF. I'm going to call it X equals AB, which is 10, divided by 5. But that's squared. And I can't forget that. And it's got to be in parentheses. So now this 36 over X weights to see what happens on this side. And 10 squared is 100. And 5 squared is 25. And then we cross multiply and we get 100x equals 36 times 25. So if I go off to the side here, 36, 25, 6 times 5 is 30. 5 times 3 is 15, plus 3 is 18. Another 0. 6 times 2 is 12, carry the 1. 2 times 3 is 6, plus 1 is 7. And that's 0. 8 plus 2 is 10, carry the 1. 7, 8, 9, 900. So if I divide both sides by 100, I get X equals 9. Okay, so the area of triangle DEF equals 9 centimeters squared. So there's my answer. You should always give the answer with your unit of measure. Okay, centimeter squared, centimeter squared. Okay, so now you should be able to do problems numbers 19 and 20 in your exercises. Okay, so here's example 6. We have to decide whether this pentagon and this pentagon are similar. So we're going from here to here. It's getting smaller, so we want the smaller numbers on top. So let's do the perimeter in red of the red pentagon. P equals, we'll start with KL and go counterclockwise. 8 plus 8 plus 6 plus 4 plus 6 equals 8 and 8 is 16, and 6 is 22, and 4 is 26, and 6 is 32. And then I'm going to switch to blue, and this perimeter is going to equal 12 plus 9 plus 6 plus 9 plus 12 equals 12 and 9 is 21, 27, 36, 48. Okay, now if I draw a line under in between each of these, make them fractions like so, I'm going to get 8 over 12, which reduces to 4 goes into 8 twice, 4 goes into 12 3 times, and these should be equal, remember. And 8 over 9 doesn't reduce. We have problems, people. Here's 1 over 1 equals 4 over 9 equals 1 over 2. And here we got 32 over 48, which reduces to Let's see, 16. 16 will go into 32 twice, 16 will go into 48 3 times. So we got a scale factor of 2/3 of our perimeter. Our perimeter scale factor was 2 to 3, or 3 to 2, 2/3. But each piece is not equal to 2/3. So therefore, this is not similar. These two polygons are not similar. The book shows how they scaled it down and reflected it, and it didn't match, but this proves it right here. Our K's cannot be all different. Our K's should equal the perimeters ratio, and they don't. And that is your explanation. So after doing that problem, you should be able to do problem number 25 in your exercises.